start screaming?
No, definitely not.
Definitely?
Definitely not.
Oh, okay. Good to know.
All right, guys, this is called the second derivative test today.
What? Oh.
It does not mean you are taking a test, okay? That's what it is called. All right. So guys, do you remember how the first derivative told us about the slope of your original graph, like whether it had a positive or negative slope, right? Second derivative tells us about the concavity of the graph.
Wait, like the concavity?
Yeah, like the curving, like this is concave down, this is concave up.
Wait, so it just tells us about the, like, a concavity?
Yeah, so like if you had a graph that is like doing this, these places where it changes from like this is concave down,
Yeah.
this is concave up, this is concave down. Like you can get that information from the second derivative. All right, so the way this works, if f double prime, so second derivative of x, if that is less than 0, the original f of x is concave down. And if double prime of x is greater than 0, our original function is concave up. And then if the second derivative equals 0,
Oh, so they didn't keep
Aiden's taking the test. Yeah, Aiden and Rebecca. I didn't miss anybody else who still need to take
I
it.
to like take the notes for them.
No, you can watch the video.
No, that's
When it's 0, you may have a point of inflection. And guys, a point of inflection, that just means like a change in concavity.
so like, is that like a quotation mark in between?
That's f double prime.
Double prime.
Yeah, this is the second derivative, f prime prime. Okay. Which you did a little bit on your review, right? The second derivative just means the derivative of the derivative. You just keep going, so.
Is there a derivative?
Oh yeah, you can just keep going. Eventually they're all gonna end up just being 0, right?
So it doesn't have a chance that it was 0.
There's a chance that it was 0. Probably wasn't, but there's a chance. All right, let's try one. Let's see, f of x is equal to 2x cubed minus 3x squared minus 12x plus 8. So there's our original function. You're going to tell me where is this increasing, decreasing, concave up, and concave down. Okay. Do you want to try? Try the first derivative part. Increasing, decreasing. See if you guys can figure that part out. Do we know what to do?
Oh, we know, yeah, we got it.
Some number line involved?
I was joking.
Okay. All right, so you guys, I'm not really giving you directions here. Increasing, decreasing. Up or down. Tell me those intervals, okay? while I try to take attendance with no one here. And you guys are welcome to move seats, right? Like if you're happy where you are, you don't have to just stay all spread out.
Feels so like weird in here.
Weirdly empty.
Pretty funny.
Flush. How are we doing on the first derivative, guys? We got that? Okay. All right, so we need to know where this derivative is equal to 0. Are you guys fine with me just getting rid of the 6's, like
Yeah.
dividing? Okay. All right, so what did it factor into?
X plus 1.
Are we okay there? All right, so what goes on my number line?
-1.
Okay. All right, so those points are either maximums or minimums, right, with our original graph here. What did you test?
0.
0. Okay, that lives in the middle. Gives me positive times negative. Are we okay with that much? Okay, so where is this one increasing?
0, 2,
Where else?
to negative.
Okay, start on the left and go to the right. Yes. We got to do them in order. And then 2 to infinity. Okay, where is it decreasing? Okay. Let's see. Do you guys think you can find your relative max and min for me? So let's think about, let's sketch it on here. Where it's positive, it's increasing. And then where it's negative, it's decreasing. Oops, I didn't go for that. Decreases, and then it starts increasing again, right? That's the like general, really rough shape of my graph. Not at all on a grid or anything, but that's the idea. It's increasing, decreasing, increasing. So at -1, is that going to be a max or a min? A max, okay. So I've got a relative max at -1. What? How do I find the y part of it? Plug it into the original. All right, guys, plug in -1. What do we get? We should, I'm writing it a weird way. Okay. What'd we get? 15. Yeah, so you've got a relative max of 15 at x equals -1. Yeah, plug it into the original. Because the graph, like the little green squiggly graph, yeah, that's a cubic function, right? And that's what our original was. Like we're finding the maximum of that. If you plug it into the derivative, you're just going to get 0 every time. So we're talking about all of these characteristics, the increasing, decreasing, maximum, minimum, concave up, concave down, all of that is of the original function, okay? So what is the relative minimum? Yep, so -12 at x equals 2. Okay, so all of that is from the first derivative. We're now going to do a similar process, but with the second derivative. So we'll switch to purple for that one. So guys, what's the second derivative of my function? 12x minus 6. What do you think I should do with that derivative? Set it equal to 0, yes. And you can factor out and divide by the 6 right away if you want, or we can just solve for x. What do we get when we solve for x? 1/2. Okay, same process, right? Set it equal to 0. Now we set up a number line. There's only one point on the number line. Okay, if I test 0, what do I get? Positive or negative? Negative. We're kind of, this is like the factor that we're plugging it into here. So I get a negative. Bigger than 1/2 will give me a positive. Okay. What that means is from -infinity to 1/2, your graph is going to be concave down. And then from 1/2 to infinity, it'll be concave up. Okay. Concave down. And we're going to make a sketch here so you can see all of this. And then what do you think is happening at 1/2? Point of inflection. Yes, so let's find our point of inflection. So we know the x value is 1/2. Again, what do you think we're going to plug that into? Which of these equations? Because we now have a lot of equations. The original. Yeah, again, these are all characteristics of that original graph. I know you love plugging in a fraction, but it's not too bad. Into the blue, yes. So 1/2 cubed is 1/8 times 2. Okay. Minus 3/4, right? Plus 8, yeah. How are we doing, guys, with our fractions? What'd you get? Good job, Simon. 3/7. Okay, so all of that can be found from the second derivative. Questions so far? it's not really that different than what we were doing in skill 11. It's just like another layer of it, okay? So what I want you to try now, I want you to sketch f of x. Thinking about maximums, minimums, point of inflection, increasing, decreasing, all that stuff. All right, which part do you want next? 11. The blue one. Will you grab one of those? Thanks. Have fun. All right, so I'll give you guys a minute to try. You have all the information, so it shouldn't be too bad. Okay, I'll make it available to you. Okay. I know you're excited. Okay, guys, looking at the graph. Easy enough? Okay. And something to note, you see this point of inflection. First, can you tell that it changes concave down to concave up? Like, can you see it kind of? Where is this point, like, in relation to the maximum? It's right in the middle, right? Both vertically and horizontally. Okay, so that's just something to be aware of when you're sketching it or finding those pieces too. It's always going to be in the middle. Questions on the first one? Okay, we do not have that much left. All right, this one, your brain will think a little bit on this one, okay? All right, I am giving you the graph of f of x. Sketch f prime of x and f double prime. That's f of x. And obviously it's not going to be perfect. I'm not going to give you any points, like just the general shape there. Okay. I'll give you some time. Like, you got to just think. Different colors actually help on this so that you don't get lost in all of your graphs at the end. You got it, Ethan? Or are you thinking?
I'm thinking.
Okay. It takes a minute. Might take a few minutes, yeah. It's hard. Like, you get there, but you just, it's... Okay. Simon's on fire this morning.
Is there like any consistent relationship between the first one and the second?
Am I slow?
So think about the one we just did here. The maximum and the minimum were, how were those related to the first derivative? What did the first derivative equal at the maximum and minimum of this original graph? So, nope, what did the first derivative? What happened at the first derivative at -1 and 2? I think you guys were saying it over here. Sarah, did you say it? Yeah, right? Aren't the max and min of the original graph where the zeros of your first derivative were? The x-intercepts of your first derivative? Okay. Thinking. Other things to think about, guys, that looks like a 4th degree function to me. Both ends are going down and I see like 4 zeros happening. So I know the first derivative is going to be a cubic. The second derivative is going to be a quadratic. Like, you gotta piece all of that stuff together. This is not easy. This is the tough stuff in Skill 12, is connecting it all to the graphs. Got it? Okay. What'd you ask, Carla?
So we need values assigned to the zeros.
No, but we have to leave it. So, that's,
Like, I will tell you, so I'll do my first derivative in red. This is a maximum right here, right? So I know that at that same x value, my first derivative is going to have an x-intercept. Same thing with, we'll call that a minimum. That's maximums. Makes sense. I went from 4th degree, now I'm at a 3rd degree because I've got my 3 x-intercepts. The slope part, I actually think it's the hardest for you guys to see, so look up here for a second. We all agree that this is a positive slope, all the way to where the red dot is, right? That means for my first derivative graph, it has to be above the x-axis. So this is where it's hard for your brain, because this is a positive slope, but this section of the graph is going to go like this. Positive slope here because this is above the x-axis. It's okay that this graph has a negative slope. That's like your brain like is fighting that, but positive slope here, so we know we're above the x-axis. Now look from this red dot to here. Negative slope. So where do I know the red graph needs to be? Below. Negative slope, right? We want a negative derivative, so it's going to be below the x-axis. Then what's happening from here to here? You guys see positive slope, so it'll be above the x-axis again. We're doing derivative stuff. Grab. Yes, like whichever one. And then from there to there, negative slope, so we know we're going to be below the x-axis. Ethan, you look like your head just exploded a little. So that's the first derivative. Did you get it right, Frank? Nice. So now try your second derivative. Now the weird part with the second derivative is you can use all the concavity stuff from the blue graph, or you can like pretend the blue graph isn't there and just do what we did again with the red graph. The second derivative of blue is the first derivative of the red one. Yeah, I know. Oscar, you go. You see it? Yeah, it's.
So you just do the same thing to the second derivative one, then, right?
Yeah, you can look at the red graph and look at the max and mins there, and they'll line up with the points of inflections from the blue graph. I know, it's weird. It's like so much information all at once. Upside down parabola? Yes. We'll talk about why it's upside down here in a minute. Alright, so I'll do the second derivative in green. Again, two ways you can look at it. I can look at the red graph and go, okay, I think there's a minimum there and a maximum there. Do you notice how those match up with where the points of inflection are for the blue graph? Yeah, so they end up being my x-intercepts for my second derivative. And then again, two things you can look at. The red graph, and both here, negative slope, right? So where should my green graph be? Under the x-axis, right below the x-axis. And also look at the blue graph. What kind of concavity does that have? Concave down, right? So that means under the x-axis. Okay. So I'm down here. Then from green dot to green dot, do you see positive slope on the red one? And concave up on the blue one? So I have to be above the x-axis there. And then that last bit, negative slope, concave down with the blue, so I gotta be below the x-axis. Okay, let's talk about the front. Kind of fascinating. Like, I think it's interesting, right? The way it all visually works together. Another thing to think about, the original blue one, it definitely had a negative in front. Like, it's a fourth degree, but with both going down, you know, there was a negative. So when you start taking derivatives, your first derivative is also going to have a negative leading coefficient, and that's what that cubic graph is doing. And then second derivative, a negative coefficient, so it's also going down. So it all makes sense. Okay. All right. Questions? We'll definitely do more with that, especially when we get into graphing the trig derivatives and where those come from. So your trig graphs will come back a little bit, the parent graphs. Any questions though? Okay, that's the end of notes. So they're not long. They just kind of make your brain hurt a little bit at the end there.
What are you going to name? All right.
Cases.